everybody, welcome back to Mr. Marlowe's 6th grade online math class. Today we're going to be working on lesson 11 from module 6, and this is using the mean, median, range, and MAD to answer a real-life question. Today's target is I can use the mean, median, range, and mean absolute deviation, MAD, of a data set to make decisions. Okay. We have some vocabulary, just like yesterday. Maximum is the highest value. Minimum is the lowest value. Mean is the average of a set of numbers, the equal share or balance point. Mean absolute deviation, or MAD, is the average distant points in the data set, lie from the mean. Range is the difference between the maximum and the minimum values. And median is the middle number of the data when the data is arranged from least to greatest interval, a set of numbers or distance between two numbers on a histogram. So we're going to go over a couple more of these questions just to really kind of drive this idea home. Which question is a statistical question and why? The first choice is how many red M&Ms come in a small packet. The second choice is which color of M&Ms is Mr. K's favorite. So pause the video for a second and think about which one of those is a statistical question. Well, the first one is a statistical question because it can be answered by collecting data that is variable, okay, or collecting a number of different data points. Just simply asking somebody what their opinion is on the favorite color of M&M is not a statistical question. Okay. So now we want to look at, are the answers to these statistical questions numerical or categorical? And if you remember from yesterday, numerical, you can think of the word number, right? You can think of the word number. So do we collect numbers to answer the question? Or does the question, can the question be answered categorically or by using categories? So how many words per minute can 6th graders type? Well, this should be your dead giveaway on whether or not this is numerical or categorical. This part right here, how many? How many implies a number. Okay? And if it's a number, then it's going to be numerical. How many sit-ups can 6th graders do? Would be a numerical question. On average, how long does it take a 6th grader to run a mile? Would be a numerical question. All right. The second one, what flavors of ice cream do 6th graders like at DCS like? Well, that would be categorical. 6th graders like chocolate, or they like vanilla, or strawberry, or cookies and cream, or whatever it is, right? Those numbers fall, or those answers, sorry, fall into categories. So part C here is looking at a histogram, and the question is, what is the length of each interval in feet? Well, remember the interval, right, is going to be found on the x-axis. So the interval is the width of this rectangle. And what is the width of this rectangle? Well, I could find that by taking this second number and subtracting the first. And 65 minus 60 is 5. So I know the interval is going to be 5 feet. Oh, yeah, 5 feet. And I can check over here too. What's this interval? Right here. Again, what is the width of that rectangle? Well, I can find the width of that rectangle by taking the second number and subtracting the first. 75 minus 70 is 5. So I know the interval or the width of that rectangle is 5 feet. So here are some of the same dot plots that we looked at from yesterday. Okay. And I just want you to remember that if our data is symmetrical, right, or if it's more or less even on both sides, the mean and the median are going to be very close together. But if our data is skewed at all, like in this dot plot, which is skewed left, our mean and our median are going to be farther apart. Okay? So again, when the data is symmetrical, the mean and the median are close together, and when the data is skewed to one side, the mean and the median are farther apart. So here's a histogram of the gross monthly salaries for part-time lifeguards. And what do you notice about this data? Okay. Well, pause it and think about this for a second. Think about maybe first, what's the shape of this data? Is it symmetrical? Is it skewed right? Or is it skewed left? Pause the video and think about that for a second. Well, if I draw a line around this data, I'm going to fix up that bottom part a little bit. If I draw a line here, which way does the tail point? It's not really symmetrical, right? The tail kind of trails off to the right. That's because the data is skewed to the right. The intervals, well, what are the intervals? Right? Well, the intervals for the data, ooh, look at this. This is a little bit tricky. I can't just simply subtract these two numbers, although that would be my first step, but how many rectangles do you see between those two numbers? There are 4, correct? So there are 4 rectangles per $100. So I know my interval is going to be 25. Okay, the minimum, well, what's the minimum? It's about 800. Okay, and the maximum, well, where's the maximum value here? Okay, the maximum value, I'm going to erase this just so we can see a little bit better. The maximum value isn't 1800. The maximum salary looks to be about 1500, right? Right about there. So then the range, remember, if we want to find the range is the difference between the maximum and the minimum. So the range is about 700. And what do we think the center of the data is, just by looking at the picture? So where's about, do you think you could estimate, just by looking at this graph, about where the center is? So do we think the center of the data is over here somewhere? Because that's the center of the graph, that's the center of the x-axis? I wouldn't say so, right? Because most of our data is clumped over here to the left. So if I were to guess what the center is, I'd say it's probably somewhere right about there. Just eyeballing it, that looks about to be the center. Now notice that the peak is off to the left of the center, but that's okay because we can see that there are actually probably more data points to the right. So if we were to take the mean of this, the center would probably fall somewhere right around 950. So here's another example of a histogram. Okay. And this data set compares the size of a band to how many times they appear at a popular music venue. And what do you notice? Well, in this case, now remember it's not perfect, but the data is more or less symmetrical. Okay? The interval, well, what's the interval? Remember, the interval is going to be the width of this rectangle, or the width, I should say, the width of each of the rectangles. And the width of each of the rectangles is how much? 1. That's also 1, that's also 1, that's also 1, that's also 1, right? The range is going to be the maximum value minus the minimum. And of course, 6 minus 1 is 5. So my range is 5. Not even knowing what the numbers for the median and the mean are, do you think they will be close together or far apart? Now remember what we said about the mean and the median and how they're affected by symmetrical or skewed histograms, right? A symmetrical histogram is going to have a mean and a median that are close together, while a skewed histogram is going to have a mean and median that are far apart. Okay, so in this case here, I would guess, I don't really have to guess, I can tell you, and you should know, that the mean and the median are going to be close together. They're going to be somewhere kind of right around here. And what do you think the center of the data is? Well, again, because this graph is symmetrical, I can guess that the center of the data is going to be right about the center of the graph. So right around 3. Okay. So wrapping it up, when the data is symmetrical, the mean and the median are always close together. And when the data is skewed, the mean and the median may be farther apart. That's it today. If you guys have any questions,